Okay, so this is one of the more straightforward tutorials. There are only a couple steps to it. First, you're going to be creating a FASTA file. You're going to be handing that FASTA file to the protocol that creates the canonical loops. And then you're going to be picking a low-scoring model, and you're going to be rebuilding the HCR3 of that model. And then we have a couple of the little things where you look at some structures in PyMol, and you identify clusters using a program that's also built into the Rosetta package. And so I guess we'll get started. This first step is kind of optional. It just, if you set these environment variables, you're able to get around kind of specifying where the grafting database is, for example, and yeah, it sometimes is kind of convenient to do that. So I guess we'll start. We'll just make this directory my files, which I think I already have the directory made. You would just make dir my files and then cd into it. And then I guess I'll cp I'm going to copy the existing FASTA file instead of making it again. That you just say you want to copy it. And then, yeah, this is just kind of a note. We're just going to go ahead and run antibody. What's it? Dash FASTA. Cool. Okay, so as I said before, I added the environment variables that made it so that I didn't have to specify the grafting database. And I have last P already in my path, so I didn't have to explicitly state that. So as you can see, it's running successfully. These runs do take a pretty long time, actually. So I would choose to use the provided output data instead of waiting for them to complete, because I think it's about half an hour per model that you want to produce. So I think it's definitely not worth waiting. So I'm just going to go ahead and cancel it with Control C, and then we'll go ahead and open a relaxed model, and we'll fetch the native structure from the PV. And then we're going to align both of them, just align two, all one word. And then we're able to see here that, the CER1 and 2 look pretty good. CRH3 doesn't look particularly great, but this is one of the early models. This is not with the H3 rebuilt. So we'll see how the final model does. But all of our other CDRs look pretty decent. So yeah, I guess we'll go on to the next step. Okay, so I guess we're just going to run the identify clusters command now, which we have here, and it should be immediate. And then we're just going to cat out the file that we told it to write to. So this will tell us the north and back cluster that each of our canonical loops was assigned to, and it will also tell us a distance from our loop to the cluster that it was added to. So yeah, and now I guess we'll just run the loop modeling command. So this will actually use a set of flags that we're going to copy from the input files. So yeah. And if you are going to be building a lot of antibodies, it's worthwhile to read all of the available flags, because there are some that let you kind of constrain the internal side of the CDR3. And yeah, so there are a lot of options available. But the Rosetta documentation should be pretty good on that. We'll include links around here to read up on all of the available flags. But that's most of what you need to know to run Rosetta Antibody.